Hi everybody. Today I get to talk to you about some laws of logic. You're going to watch this video, and if you have these pages printed, that would be great, or if you just could get a look at them ahead of time, work out some of these ideas, you're going to want to memorize these first 5 laws. I'm going to show you 5 laws of logic, and we're going to apply them. The first one's called the law of detachment. And here's some things I need to tell you about it. We're going to decorate that page with a line here. Everything above that line are called premises, and we accept them to be truthful. After the premises, then we're going to draw a conclusion. We'll begin with a simple conditional, if P then Q, and we know that P is true. Therefore, what conclusion could you draw? We'll say, well, the conclusion is fairly obvious, it would be Q. But what you got to remember is, when you use a simple conditional and you know the hypothesis is true, when you conclude this, you got to call that the law of detachment. Another one. Here are our premises accepted to be true. We would like to draw a conclusion. If P then Q, and we also know if Q then R. What conclusion should you draw? I bet we can agree. It would be if P then R. You can think of lots of reasons, lots of examples. If I study hard, then I can make good grades. If I make good grades, then I can get into college. So that would say, if I study hard, I can get into college. That chain of logic, we're going to call that the law of syllogism. Another interesting one that you want to study, the law of contrapositive. If P then Q, but we have the denial of Q. Therefore, what conclusion can you draw? If P gives you Q, we know this to be true, but we do not have Q. This leads me to the denial of P. We'll call that the law of contrapositive. I hope you remember that a conditional is logically equivalent with its contrapositive. So if this statement were true, its contrapositive would have been true. If not Q, then not P. And since we say that not Q is true, and we know that this conditional is true, we can conclude not P. This part is called the law of contrapositive. That's what you have to recognize. And this is just my rationale. Here's one called the disjunctive syllogism. Here are our premises. Here we'd like to draw a conclusion. You should pause the video and make that conclusion before I tell you. It's P or it's Q, but it's not P. Therefore, what conclusion might you draw? I'd say it must therefore be Q. It's right or it's left, but it's not right. Therefore, it must be left. That's the law of disjunctive syllogism. That's how we'll name it, a disjunctive syllogism. There's only one more law. These two instances of the same law, they're very related. Not P or Q is logically equivalent. I got an equal sign here. To correct that, I should put 3 bars. That would indicate logically equivalent. And when you bring a negation through a parentheses, like in an algebra class, it goes to both parts. It goes to all the parts, but it goes to both parts here. It would become not P. Interestingly, though, the or becomes and, not Q. When you bring a negation through a parentheses with a disjunction, it becomes a conjunction. But the negation goes to both parts. Similarly, another instance of De Morgan's law, when you bring a negation through a conjunction, what do you figure would happen? You ought to pause the video and write that, then we'll agree, and you'll feel good about that. Not P, and becomes or, not Q. It's not true that Paul and Quincy came. It means either Paul didn't come or Quincy didn't come. It's not true that Paul or Quincy came. That means Paul didn't and Quincy didn't. We'll call those De Morgan's laws. We'll apply them. Here's a couple of instances of that. They'll start simple, but I think you'll find that they get more interesting. If I can borrow my dad's car, then you can count on me for a ride. I'm going to use this. I capitalized the words I wanted to represent this phrase. I'm going to use B to say borrow my dad's car, and R, you can count on me for a ride. So this would be a conditional. If I can borrow my dad's car, then you can count on me for a ride. We're just going to code these things. And the next premise is I am able to borrow my dad's car. I have B. therefore. And I'm going to write the conclusion over here. And your conclusion would be, if B then R, we have B, by golly, we would have R. But on the right, I should write out my conclusion and tell what rule I used. Yep. I could conclude, you can count on me for a ride. And what rule? I used the law of detachment. You'll recall the law of detachment, just a simple conditional, and the hypothesis is known to be true, therefore we can conclude the conclusion. That's what was happening here. Let's look at another. It's not true that both Robert and Joe caught fish. I'm going to use R for Robert caught fish and J for Joe caught fish. And it's not true, that sounds like a negation to me. It's not true that Robert caught fish and Joe caught fish. And I want to draw a conclusion from this. Actually, I'm going to find something that's logically equivalent with it. So you're sorting through these set of rules and you're thinking, well, when you bring this negation through a parentheses, that and will become or. My conclusion? Not R or not J. But to get a good score on this paper, I'm going to have to write my conclusion out and tell what rule I just used. I conclude Robert did not catch fish or Joe didn't, and I used De Morgan's rule. I got some more. I think they're going to get more interesting. Let's take a look, please. If lines are perpendicular, then they form right angles. L and M do not form right angles. You may have a conclusion, but the exercise here is to put these into symbolic form and tell what laws you're using. I capitalize P. Let's let P represent lines are perpendicular, and R represent they form right angles. So we'll have the conditional. If lines are perpendicular, then they form right angles. Under the premise, L and M do not form right angles. That's not R. And we want to draw a conclusion. We want to draw a conclusion and recognize which of these interesting laws were used. So you have to be very versed in these rules. You can keep that paper handy. If P gives me R and we have the denial of R, that leads me to the denial of P. Over here I should write that out and tell you what law I used. You decide what law I just used. My conclusion, lines L and M are not perpendicular, and my rationale, the law I used, was the law of contrapositive. We'll play some more. This is a good one to pay attention to. If my truck is out of gas, then it will not start. My truck will not start. Let's use G for out of gas. Then I'm going to say not S for not starting. If we're out of gas, then it's not going to start. And my truck will not start. Is there a conclusion that we should draw from this? Pause the video and write your conclusion. Let's talk about that. Actually, there is no conclusion. No conclusion can be drawn. If one were to come to a conclusion here, no conclusion is what I'm scribbling there. If one were to come to a conclusion here, if you would have decided G, then you would be reasoning from the converse. That would be false. There is nothing that we could say here. If you had decided to say G, then you must have thought that this was logically equivalent with its converse. If not S, then G. And then you could come to a conclusion, but these are not logically equivalent. A conditional and its contrapositive are not logically equivalent, and there is no conclusion you could draw here. If you were, you would be reasoning from the converse, which is a very common error. We'll avoid it. Let's look at another one. I'll be at work on Monday, or I'll be helping Helen move. I'm going to use W for work on Monday. In helping Helen move, I'm going to use M. I'll be at work on Monday, or I'll be helping Helen move. I am not at work on Monday. Not W. What conclusion can you draw? M. So you write on the side, I concluded M. What does that represent? I'll be helping Helen move. What rule did I use? And I sort through this stack of rules that I've just learned about and which rule was applied here, that's really what this game is about. We have a disjunction, and to deny one of the disjuncts, that's a disjunctive syllogism. These next few use a couple of rules. That makes it more interesting. Let's code these and to see what rules we can apply. It isn't true that Joe was absent or Henry skipped school. I'm going to say Joe being absent is A and Henry skipped school is S. It isn't true, indicating a negation, that Joe is absent or Henry skipped school. Then we have a conditional if Joe was not absent, then he will have the notes. If Joe was not absent, then he will have the notes. And let's use N for having the notes. Let's call this in statement 1 so we can refer to it in statement 2 as we use these two premises to draw a conclusion over here. Something that occurs to me right away. I can bring this negation through the parenthesis. An example of De Morgan's rule. Let's call that statement 3. I'll bring that negation through the parentheses. It would become not A and not S. I'll abbreviate that De Morgan's rule, and I just applied it to statement number 1. So when you look back at that, you might recognize that means he talked about De Morgan's rule. He brought that negation through that parentheses. Let's look at the 4th statement and see if we can think of something to do here. And this is a little bit of a trick. If this is an and statement, and we accept it to be true, and it says these conditionals, the premises are true, this must be true, we could take either half of that and statement we like. I choose to take the not A. That's called a simplification. I just simplified statement 3. It was an and statement, I took the half I wanted. But now look at statement 4 and statement 2. If I have not A, then I have N. And we have not A, If I have not A, then I have N. We have not A, therefore we have N. I got to tell you what rule I just used and tell you what that represents. That's what I'll do right away. You think about it before I tell you. I hope we agree. That would be the law of detachment. The law of detachment, just a simple conditional. We know the hypothesis is true, therefore we come to this conclusion. That's what was going on here. We had this conditional, and the hypothesis was known to be true. And the hypothesis was known to be true, therefore we can conclude N. That's the law of detachment. Let's look at another one. If the water's clear next weekend, then I'll go fishing. I'm going to use C for the water's clear next weekend, and I'll use F for going fishing. If the water's clear next week, then I'll go fishing. And another conditional, if I go fishing, then I'll catch a big redfish. Let's use R for a big redfish. Third premise, I will not catch a big redfish this weekend. That would be the denial of R. I'm not going to catch a big redfish. Because we have 3 of these, let's number them so we can refer to them and make some decisions. There's a couple ways you can approach this, I'm sure. But look at statements 1 and 2. If C, then F, and if F, then R. I'm going to call this statement 4 and put these two thoughts together. Truly, if C, then R. That's an example of the law of syllogism. You'll recall when you have 2 conditionals and the conclusion of one is the hypothesis of the other, we can hook them together. Isn't that what's happening here? If C, then F, and if F, then R. By golly, if C, then R. But now look at statement 3 and statement 4. If C, then R, but we have the denial of R, statement 5. That leads me to the denial of C. So on the right, I got to talk what that means. That would mean not C, therefore the water was not clear. And then I got to tell you what rule was used. Water was not clear. If C gives me R and I deny R, then that leads me to the denial of C. That's the law of contrapositive, and we should write that over here too. Law of contrapositive. And we've got one more to look at. If Paul is at the party, then George or Ringo will be there. Paul did go to the party, and Ringo did not. If Paul goes to the party, this is a conditional, then George or Ringo will be there. Paul did go to the party, and Ringo did not R. We'll probably have a little chain of logic here. Let's work with statement 1 and statement 2 and make some decisions. Here we have a conjunction. We know that both parts of it must be true. It's a premise, and if a conjunction is true, then both parts are. So on my statement 3, I'm going to say P. I think I just simplified statement 2. But then I look at statement 1 and statement 3. If P, then G or R. We have P. Therefore, we have G or R. That's an example of the law of detachment. Just using a simple conditional. Detachment. Just want to make a note about what rule I used. I used the law of detachment on statement 1 and 3. So someone looking back at this would figure out what I was thinking. Then I think, I have G or I have R, but truly I don't have R. I want to simplify this statement. I'll take the half I want. I'll call that statement 5. And because this conjunction is known to be true, then by golly, not R must be true. That conjunct must be true. And that's just a simplification of statement 2, like we did a minute ago. And then I'm thinking, either it's G or it's R, but it's not R. Therefore, what conclusion would you draw? I'd say it's got to be G. It's either G or it's R, but it's not R. It must therefore be G. That's a disjunctive syllogism. And you remember that what a disjunctive syllogism looked like this. Given a disjunction and deny one of the disjuncts, you can conclude the other. Is that what happened here? We had a disjunction and denied one of the disjuncts, therefore we conclude the other. Therefore, I guess George must have been there at the party. I'm going to write a series of questions like this. You're going to email me when you have questions about them, and then you'll get a chance to practice, and it'll be great.